All right, well, welcome back. We're going to be doing another lesson today on permutations and combinations. Today's topic is on 4.2, factorial notation and permutations. I've actually divided this lesson into two parts, part A and part B. Today we're going to be looking at factorial notation, and then in the second video, we'll be looking at what a permutation is. Now, this unit is called permutations and combinations. So before we get into factorial notation, we're going to talk about what a permutation and combination are. I often shorten it to perm and com. So I've got two scenarios here. The first one says the combination lock for your locker is 26, 10, 31. The order that you put these numbers in is very important. When you're doing your locker combination, if you don't put the numbers in the correct order, you mix things up or you go past your number a little too far, you're not going to be able to open your lock. So this is an example where order is important. There's another example. It says when you play a game of cards, in your hand you have 3 aces and 2 kings. That's called a full house in poker. Generally, when you're playing cards, it doesn't matter what order the cards are in your hand. It just matters that you have the combination you need. And so in this case, order is not important. So in this unit, we're going to be talking about permutations and combinations. If we look at these, the first one, order matters. This is an example of a permutation. And in the second one, order does not matter. And so this is an example of a combination. And so we're going to start by looking at permutations and then eventually look at combinations. So it's really important that you understand a permutation, order matters. A combination, order does not matter. All right, so we're going to get into looking at factorial notation. And so we've kind of looked at some examples that would relate to factorial notation in the last lesson, but you wouldn't have necessarily known what a factorial was at that point. So consider the example where I have 5 books on a shelf and I need to arrange them. So I have all 5 books, I want to put all 5 books on the shelf, and I want to arrange them. Well, if we go back to the fundamental counting principle that we did in the last lesson, we would have set up our blanks. We would have had a blank here, 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 and here. Those are our 5 books. And we would have had 5 choices for the first book, 4 choices for the second, 3 for the third, 2 for the fourth, and 1 for the last one. And we could have multiplied that out. So 5 times 4 times 3 times 2 times 1 would have given me an answer. So let's see, that's 20 times 6. So 20 times 6 would have been 120. So there would have been 120 different arrangements that we could have. Now, when we're multiplying from 5 times 4 times 3 times 2 all the way down to 1, this is called factorial notation. Or sorry, this is an example of factorial. So we can write 5, 4, 3, 2, 1 as factorial notation. And notice it's 5 with an exclamation mark. This doesn't mean I'm excited, that's a really cool 5. It just means 5 times 4 times 3 times 2 times 1, which is also known as 5 factorial. So when we're multiplying 5 factorial, it just means we're multiplying from 5 to 1, and each number is getting 1 less. So we can do factorials in our head if we understand that concept. So the first question here says to write or to figure out 4 factorial without using a calculator. Well, 4 factorial means 4 times 3 times 2 times 1. Well, 4 times 3 is 12. 12 times 2 is 24. And times 1 is still 24. Now, 3 times 2, or 3 factorial times 2 factorial, don't mix this up with 3 times 2, which is 6. So this is not 6 factorial. We actually have to individually calculate these. So 3 factorial would mean 3 times 2 times 1, and then that's being multiplied by 2 factorial, which is 2 times 1. Well, 3 times 2 is 6, 6 times 2 is 12. So again, with factorials, we can't just like pull out the factorial, go 3 times 2, and then add a factorial. It doesn't work the same way. So another way that we can write factorials is we can write 5 times 4 times 3 times 2 times 1. We've done that already. Or we can cut it off earlier than that. So we could go 5 times 4 times 3 times 2 factorial. 2 factorial because 2 times 1 is the same as 2 factorial. Or we could write 5 times 4 times 3 factorial. And we can do that because 3 times 2 times 1 is the same as 3 factorial. And then the last one, oops. And then the last one here, we can have 5 times 4 factorial. And if we look at that one there, that's because it's the same as 4 times 3 times 2 times 1. So we're really just simplifying or writing these in different ways. That's important for us to know because as we get into reducing and calculating and simplifying factorials, that's a property that we can use to help simplify. So up there we have an example of how we can write 5 factorial in different ways. We can use that concept to simplify 5 factorial over 3 factorial. So if I want to simplify 5 factorial over 3 factorial, I'm always going to start by looking at my bigger number. Well, 5 is bigger than 3, so I'm going to write 5 factorial by reducing it. And I'm going to reduce it until I get to a 3 factorial. So 5 times 4 times 3 factorial. And the 3 factorials on the bottom, those can be cancelled, and I'm left with 20. So we're going to look at some other concepts related to this. So it says complete the following. We've got 13 factorial equals blank times 12 factorial. Well, this is going to be 13. 10 factorial is blank times 7 factorial. Well, that means I started with a 10. So 10 times 9 times 8 times 7 factorial. We're going to look at some other examples here. Again, we're just building on that concept, seeing how this can be used in a variety of ways. Express the following as a quotient of factorials. Well, 6 times 5 times 4. Well, this would have started off originally as 6 factorial. And what's missing at the end is the 3 factorial. So that's what we would have divided out. So 6 factorial divided by 3 factorial. If you want to see how that works, we would have gone 6 times 5 times 4 times 3 factorial all over 3 factorial, and these would have canceled. All right, the next one, we've got 16, 15, 14, all the way down to 12. That means we're missing the 11 factorial. So we started by breaking down the 16, so that's our 16 factorial. And in the bottom, the 11 factorial is what's disappeared. We're going to be building towards breaking these down algebraically, but again, I want to make sure you understand the number part before we get to the algebra part. So if I have 6 factorial over 4 factorial, I will be showing you shortly how to put these into your calculator. But if we want to break them down without a calculator, we just have to use that concept of 1 less each time. So 6 factorial can be written as 6 times 5 times 4 factorial. I want to stop when my numerator matches my denominator. And I've got 4 factorial there. These are going to disappear. I'm left with 6 times 5, which is 30. If I've got 8 factorial over 5 factorial and 3 factorial, I'm going to again start by breaking down my bigger number, but I might have to do some other pieces as well. So 8 is the biggest number, so that's what I'm going to start breaking down. 8 times 7 times 6 times, I see a 5 factorial in the denominator, so that's where I'm going to stop. Now underneath I've got the 5 factorial. 3 factorial I haven't got on the top, so I'm going to break down the 3 factorial. And what will likely happen is I'll be able to cancel even more. So 3 factorial is 3 times 2 times 1. If I start going through and canceling, I can cancel my 5 factorials. So 5 factorials are gone. And 6 is equivalent to 3 over 2. So I'm left with 8 times 7, which is 56. All right, so we're going to start looking at how this relates to algebraic expressions. So if you need to go back and review this section, please do so, because we're just going to be building on this in the next part. All right, so we've talked about factorial notation. We've used some examples. This is now the formal definition. So the formal definition of factorial notation, if we have n factorial, that's n times n minus 1 times n minus 2, and so on, until we get to 3 times 2 times 1. So each time, no matter what my n value is, I'm subtracting 1 from each previous number until I get to 3 times 2 times 1. What's important for you to note is that n is the element of whole numbers. That means our n value has to be 0, 1, 2, 3, and so on. There are no decimals, there are no negatives. So again, n is a whole number. Now there is a special case, and we'll get into this in the next segment, but a special case that we have is 0 factorial equals 1. So you just need to know that 0 factorial is 1. You can do that on your calculator as well once we've gone over the calculator bit. So if I want to write this algebraically, n factorial can be n times n minus 1 factorial. It can be n times n minus 1 times n minus 2 factorial, and so on. So just like with the numbers, we can break this down as much as we need to. So for the first one here, if I have n factorial, that's the same as n times n minus 1 factorial. If I have n plus 2, well, I start with my n plus 2. I always start with the initial expression. 1 less than that is n plus 1. And 1 less than that is n plus 0, which is n factorial. So this would be n plus 2 times n plus 1 times n factorial. Working in reverse, if I've got n minus 4 in brackets all the way down to 3, 2, 1, I start with my original expression, which was n minus 4 factorial. So we're going to take a look at how to break these down algebraically. So the first one here, we've got n plus 2 all over n factorial. So just like before, when we're breaking these down, we want to start by looking at the biggest value. So we have an n plus 2 on the top and an n on the bottom, which would be equivalent to n plus 0. So n plus 2 is going to be a bigger number than n, so that's where we're going to start. So we're going to break down the n plus 2, and we're going to break it down until it matches our denominator. So n plus 2, 1 less is n plus 1, 1 less is n plus 0, which is n factorial. And on the bottom, I've got n factorial. Those can disappear, and that leaves me with n plus 2 times n plus 1. Now, you certainly can multiply this out, but for the purposes of this question, we're just going to leave everything in product form. Now, for the next one here, we've got n minus 2 and n minus 1. So you have to ask yourself which one is the bigger value. So we always start with the biggest value. So if we look at this one here, we've got n minus 2 and n minus 1. Well, if I have a number, let's say 4, and I subtract 2, and I have a number 4 and I subtract 1, 4 minus 1 is going to be bigger than 4 minus 2. So n minus 1 is the bigger value. That's the one we're going to break down. So we're going to have n minus 2 on the top. And in the denominator, we're going to have n minus 1. 1 less than that is n minus 2. That matches my top, so I'm going to leave my factorial. I'm going to cancel these. Remember, when I cancel, I'm not left with 0, I'm left with a 1. So I'm going to have 1 over n minus 1. And the last example here, I've got n factorial over n times n minus 1. Notice there's no factorial in the bottom, so that might change a little bit what we do. So I've got an n factorial, an n, and an n minus 1. Well, the biggest value is going to be my n factorial, so that's what I'm going to break down. As well, that's the only one that I can break down because the denominator has no factorials. So I've got n minus 1 factorial. Notice there's no factorial in the denominator, so I need to go one step further. And then on the bottom, I've got n and n minus 1. So my n's are going to cancel. My n minus 1's are going to be canceled. And I'm going to be left with n minus 2 factorial. So that's how we break down the expressions. Once we know how to break down the expressions, then we can go one step further and get into solving expressions. And we're going to solve by simplifying. So here we have an example. It says algebraically solve the equation n factorial over n minus 2 factorial equals 42. So we're going to start by breaking this down. Again, we look for the bigger number. N is the same as n plus 0. N plus 0 is going to be bigger than n minus 2. So we're going to break down the denominator, or break down the numerator. So I'm going to have n times n minus 1 times n minus 2 factorial all over n minus 2 factorial. And that's all equal to 42. So that's my first step. I'm going to cancel things out. And that's going to leave me with n times n minus 1 equals 42. Now at this point, I'm going to have to multiply everything out, and there will be some factoring involved. So this is going to give me n squared minus n equals 42. So n squared minus n minus 42 equals 0. Going back to our factoring, we're looking for two numbers that multiply to be 42 and add to be negative 1. So we're going to have n minus 7 and n plus 6 equals 0. So that gives me n equals 7 and n equals negative 6. Now normally we'd say those are both our answers. However, we have a rule that says n has to be an element of whole numbers. So that means we're going to cancel this out because n is an element of whole numbers. So my answer is 7. All right, so let's take a look at how this all works with the calculator. So I'm going to be pulling up the calculator and we'll go through this. This is going to be done under your math button. So when you pull up in the calculator, if I want to enter factorial into my calculator, it's going to be under the math button. So if I want to enter 6 factorial, I'm going to type 6, math, arrow left for probability, and you can type 4 or arrow down and hit the 4. So if I want 6 factorial, it's going to be 720. If I want to do 9 factorial, same thing. I'm going to type the 9, math, arrow to the right, 4 for 9 factorial is going to give me 362,880. All right, so if I want to figure out what 10 factorial over 7 factorial 3 factorial is, I can do that in one of two ways. I can calculate each individually, so I can figure out what 10 factorial is. And then figure out what 7 factorial 3 factorial is. And divide the two. So 3,628,800 divided by 30,240. Or I can do this in one step. But it's important if you do it in one step that you get, that you make sure you use brackets. So I can go 10 math 4 divided by bracket. If we don't use the brackets, it's going to divide 10 factorial by 7 factorial first and then multiply by the 3. And that's not what we want. 4, 3, math, 4, close your brackets, and we get 120. So both of these answers will give me 120. Now we could verify this without using our calculator, using the methods we learned before. So 10 factorial will be 10 times 9 times 8 times 7 factorial, all over 7 factorial times 6. So these would disappear. 6 because 3 factorial is 3 times 2 times 1. So on the top, 9 times 8 is 72, times 10 is 720. Divide by 6. 72 divided by 6 is 12. So this is going to leave me with 120. All right, I want you to try to calculate the next two on your calculator. So pause the video, try them, plug them in, and you should get, I'll just write them down here. If you do them correctly, you should get 2,686,320. And 37 factorial divided by 33 factorial times 4 factorial, again, remember your brackets, should be 66,045. Now, that's where we're going to stop the video for today. I'm going to be doing part 2 shortly to talk about permutations, but this is where I would like to stop today. Make sure that you have a good handle on this and some practice before we get into how this relates to permutations. All right, thanks guys. Have a great day.